Go is statically typed, which means the compiler knows the exact type of every value before your program runs. This episode covers Go's built-in types: the integer family, floating point, Booleans, strings, and the type conversion rules that govern how they interact. We'll also look at type assertions, the tool you use to recover a concrete type from an interface. Go has more integer types than most languages give you, and the reason is control. When you're writing a network protocol, a file format parser, or interfacing with C code, you need to know exactly how many bits a value occupies. Go gives you that control explicitly. The signed integer family. The unsigned family, same sizes, but no negative numbers, so double the positive range. Two aliases you'll see constantly. Byte and rune aren't just aliases in name, they signal intent. When you see byte, think binary data or ASCII. When you see rune, think Unicode character. For everyday use, just use int. It's the default, it's what equals gives you for integer literals, and on every modern 64-bit system it's 64 bits. Use the sized variants only when you have a reason: serialization, memory constraints, C interop, or protocol implementation. One critical rule: Go never implicitly converts between numeric types. Even int and int64, despite being the same size on 64-bit systems, are different types. Mixing them without explicit conversion is a compile error. This strictness prevents a whole class of subtle bugs that plague C and JavaScript code. Go has two floating point types, both following the IEEE 754 standard. Float 64 is the default, what you get from equals with a decimal literal. Use it unless you have a specific reason for float 32, memory-constrained environments, GPU interop, specific API requirements. Floating point is inherently imprecise. This is not Go specific. It's how IEEE 754 works. Never compare floats with equals. The fix: compare with a tolerance, or use integer arithmetic. Store prices in cents, not dollars. Booleans are simple but worth a moment. A Boolean is just true or false. No truthiness, no coercion. In Go you cannot use 0 or nil as a Boolean. The compiler rejects it. Every condition in an if statement must be a genuine bool. This eliminates a common source of bugs in C and JavaScript where non-zero values are truthy. Go strings are more interesting than they first appear. A string in Go is an immutable sequence of bytes, specifically UTF-8 encoded bytes, not characters. Bytes. Hello is 7 bytes. Each Chinese character, sir, jie, is 3 bytes in UTF-8. Total 13 bytes, but only 9 visible characters. This matters if you ever index into a string. Indexing gives you a byte, uint8. If you need to work with characters, what Go calls runes, you need to range over the string or convert it. With range, I is the byte offset of the character start, and R is the rune, the Unicode code point, as an int32. This handles multi-byte characters correctly. String literals come in 2 forms. Double-quoted strings interpret escape sequences. Raw string literals use backticks. No escape processing. Everything is literal, including new lines. Raw strings are perfect for regular expressions, SQL queries, JSON templates, and any content that would require heavy escaping in a double-quoted string. Strings are immutable. You cannot change a character in place. To build up a string dynamically, use strings. Builder, for efficiency, or simple concatenation with plus, for simplicity. For heavy string work, import strings. It has everything: contains, split, replace, trim space, to upper, and more. Go has no implicit type coercion. None. If you want a value to change type, you write the conversion explicitly using the syntax type name. Value. This verbosity is intentional. When you read code and see int f, you know a conversion is happening and you can reason about whether precision is lost. When languages do this implicitly, you have to remember the promotion rules, and bugs hide in unexpected places. For conversions between strings and numbers, the strconf package is your tool. Always check the error from atwa and parsefloat. If the string isn't a valid number, you get a non-nil error and a 0 value. Handling it is your responsibility. Rune and byte conversions. Converting an integer to a string using string 65 gives you EA, the character with that Unicode code point. If you want the string 65, use strconv etoa 65. Type assertions are used when you have an interface value and need to recover the concrete type underneath. We'll cover interfaces in depth in episode 13, but let's introduce assertions now because they appear frequently in idiomatic Go. Always prefer the safe form with OK. The panic form is only appropriate when you have absolute certainty about the type, which is rare. For checking multiple possible types, Go has the type switch, the I. Type syntax is valid only inside a switch statement. Inside each case, V has the specific concrete type, so in the int case, V is an int, and you can do integer operations on it without any conversion. Type switches are the idiomatic way to write code that handles multiple types from a single interface. You'll see them constantly in JSON processing, error handling, and generic utility functions. Go's type system is strict and explicit by design. You get a full set of integer types for when precision matters, float 64 as the sensible default for decimals, and Booleans that accept no substitutes. Strings are immutable byte sequences in UTF-8. Len counts bytes. Use range to iterate characters. Use raw string literals for multi-line content. Use the strings package for manipulation. All type conversions are explicit type value. For strings and numbers, use strconv. The compiler catches type mismatches before your program runs. Type assertions recover concrete types from interfaces. Use the safe to-value form. Use type switches when you need to handle multiple types. Episode 8 covers control flow, if switch, and goes single for loop. See you there.